Hello and welcome to the UiPath Robotic Enterprise Framework tutorials. Now that we've learned how to create basic automation projects in the foundation training, it's time to have the robots working on more complex and robust projects. In RPA, we almost never see 100% automation. There are always exceptions. Therefore, we have to design robots that can deal with every possible situation. They need to have proper exception handling and recovery abilities, as well as effective logging and reporting functionality. Moreover, high maintainability and extensibility, reusability, and ease of development are only some of the qualities that productive robots should have. In this tutorial, we'll take a look at a template called the Robotic Enterprise Framework, which is designed to be the starting point of every automation project. We will go over the mechanisms, ideas, and workflow files behind it. By the end of this tutorial, you should understand how the template is built, how it works, and how to adjust it to automate your own processes. Later in the training, we will use the framework in automating sample processes. Alright, let's dive in. We start creating a new automation project using the UiPath Robotic Enterprise Framework. The framework files can be downloaded from this UiPath GitHub repository. The files will be integrated in Studio as a template in a future version. We have a set of files. Some are to be changed and parameterized, while others are ready-made, plug and play. I'm sure you're already familiar with the main file, the one that's run when the project is deployed and started from the orchestrator. It uses the state machine diagram and has 4 states: init, get transaction data, process transaction, and end process. Let's have a look at how this works. In the init state, the robot reads the configuration and initializes the applications. If this step is completed successfully, the robot moves on to the next state, get transaction data. If a system error is encountered, the next state that is executed is end process. In the get transaction data state, there are 2 possible courses of action. Either a new transaction comes next and is processed by the robot, or all transactions have been operated on, no more data is left, so the process comes to an end. Now, after retrieving a new transaction, the process transaction state is executed. It can have 3 outcomes. The first one is success, in which case a loop is performed and the next transaction data. The second possible outcome is business rule exception, in which some specific action needs to be taken. Afterwards, the execution loops back to the get transaction data state. Finally, the system error transition, which requires us to take the necessary steps towards the recovery from the error. That means all the applications are closed and the execution loops back to the init state in which the applications are restarted. Now, let's take a closer look at the init state, during which the robot reads the settings and starts all the needed applications. The overall exception handling is already in place throughout the framework, which is why there are try-catch activities in every state. The robot tries to initialize, and if it fails to do so, it ends the process. To check whether there's an exception or not, we set the exception object to system error and initialize it with nothing. The next steps are to read the config file and, after that, to start all the applications. We catch any exception that might come up and then set the system error object to that specific exception. Depending on the value of system error, either the get transaction data or the end process states are performed. If system error is nothing, the robot moves on to the get transaction data. If a system exception is thrown, we log a fatal error message stating that initialization failed and the robot moves on to end process. Let's go back to reading the config file. That happens only once at the beginning of the execution. The condition is that config is nothing. If we go to the variables, we see that config is a dictionary, where the key is a string and the value is an object. This way, we can store settings like numbers, strings, datetime values, and so on. We then invoke the initAllSettings XAML file from the framework folder. Let's first take a look at the arguments. There are two input arguments and an output one. The input arguments are the path of the config file, which is located by default in the data folder, and the config sheets, an array of strings, which indicates the sheets that contain configuration data. The output argument is our config dictionary to be used throughout the process. The init all settings workflow file is plug and play, so nothing in it needs to be changed. Let's take a look at what the default config file looks like. It has three sheets: settings, constants, and assets. In the settings sheet, we can store any configuration related to the business process, such as URLs, file paths, credential names, and any process-specific piece of information. By default, there is the name of the queue to be used in the process. There are three columns: name, value, and description. The name column always contains a string, which is the key in the dictionary. The value field holds the dictionary value. The description column provides a detailed account of each setting. The constants sheet stores technical settings that are useful for developers. It contains information such as the number of retries, timeouts, delays, image accuracy settings, and static log message parts. Instead of hard coding timeouts or delays in our projects, we can use the config object, which enables an easy global value adjustment. This way we can fine-tune the projects, improve their performance, and easily switch their environments from dev to test, and then to production. A very important setting is the max retry number. It is used to retry the transactions that have failed with an application exception or system error. The template is designed to work with orchestrator queues by default, but it can easily be adapted to suit other types of input data, such as Excel files, emails, files, folders, and so on. As you already know, orchestrator queues also have a native and powerful retry mechanism. We're surely going to make good use of it later. So, by default, the max retry number setting in the config file is 0. The number of retries is set in orchestrator. Of course, if the queue's functionality is not used, the value of max retry number can be changed, allowing the robot to retry failed transactions. And we will exemplify that in a later tutorial. Okay, now that we've just finished reading the settings, the next step is to invoke the kill all processes file. This is done in the beginning to make sure the robot starts in a clean and controlled environment. Next, start all the applications. The XAML file should be parameterized depending on what applications are used in the process. Going back to the main view, let's now focus on the get transaction data state. Here is the data retrieval mechanism necessary to complete a transaction in our process. We define a transaction as the repetitive part of our process. With each execution, the transactions are numbered. The attained value is stored in the transaction number variable, whose default value is 1. The next important variable is transaction item. It's a queue item, but its type can be changed if a different one is needed. First, we check if a stop signal was sent from orchestrator. If so, we soft stop our robot by going to the end process state. If no stop command is received, we invoke the get transaction data file. Let's have a look at the arguments. We pass two input arguments: transaction number and the config dictionary. We also get a bunch of output arguments, out of which the most relevant is transaction item. The others are used for logging purposes. If we open the project file, we can see that the first activity is get transaction item, which outputs a queue item. The transaction ID output argument should be unique for each transaction. By default, it's set to the current system timestamp. However, it should only be used with a different value when the transactions in the business process do not have a unique ID. Here's an example. If our transaction item is a ticket in a support ticketing system, the ticket number is unique and it can be used as the transaction ID. Now, at some point, all the transactions end up being processed, so there is no more work for the robot to do, and it should stop. This occurs when transaction item becomes nothing or null. When using an orchestrator queue, that happens by default, where there are no more new items to be sent. If we change the type of the transaction item argument, we have to assign it to nothing when there is no more work to do. We will build an example of that in a future tutorial. Going back to the main view, if there is no data, then the process stops. If a new transaction comes up, then we go to Process Transaction. So let's have a look at that. We have a try-catch activity in which we invoke the process.xaml file. It needs two input arguments, transaction item and the config dictionary. Based on the outcome of the execution of the process, we can catch a business rule exception, which is always thrown by a throw activity, a system exception, which can consist of any unhandled exception thrown in the process, or no catch, which means the process has ended successfully. Based on one of those three outcomes, the new state is selected. There's one more thing to discuss, and that's in the finally state, invoking another component, set transaction status. The name is self-explanatory. As soon as a transaction is completed, it's important to set its status with the appropriate logging mechanism. There are a lot of arguments here. The config, the system error, and the business rule exception objects, which are used to determine the next state, as well as transaction item and transaction ID as input arguments. We can find the other two in-out arguments here, retry number and transaction number. They are needed as input, but they're also altered by the set transaction status XAML file. Whether or not the robot retries a transaction, the transaction number or the retry number can change. Let's have a look at it. It's a simple flowchart executing one of these three sequences. If there is no exception, the success sequence is executed. Double-click. We set the status of the transaction item to successful. If we wanted to change the type of the transaction item, we would need to delete this activity, as it only makes sense if a queue item is used. Next, we add some log fields and we log the successful message. The additional log fields are only used for this log message. This is done to add more information to the unique log at the end of a transaction. More on this in a future video on reporting. To move on to the next transaction, we increment the transaction number and set the current retry number to 0. Going back, if we get a business rule exception, we set the status to failed, the error type to business, and the reason to the exception message. Next, log the message and move on to the next transaction. Now, let's have a look at the system error. There's an extra variable in here, the queue retry flag. It's used to log a warning message if the queue item is being retried and an error otherwise. If we use queue items, the flag is true, but if we want to change the type of the transaction item to something else, we need to remove this entire sequence, as we've seen earlier. We set the error status with the error type, application, and the exception message as the reason. Next, we have this robot retry flowchart. Remember, by default, we're using the retry mechanism in the orchestrator queue, while the max retry number in the config file is 0. If the retry option is not enabled, after the first flow decision, robot retry, the no branch is executed. The next activities are a log message with level error and the increment of the transaction number, so that the robot does not retry this transaction, but instead just moves on to the next one. Now, if we don't use a queue, we can enable the retry mechanism simply by setting the max retry number in the config file to a value greater than 0. In that case, the yes branch of the robot retry decision is executed and the robot checks if the max retry number has been reached. We don't want to retry a failed transaction forever, so if the current retry number reaches the maximum value, the robot logs an error message once again and increments the transaction number. But if the current transaction has been retried fewer times than the max retry number indicates, the robot simply logs a warning. In the case of a type of a transaction other than a queue item, the robot increments the current retry number, and that's it. It doesn't increment the transaction number value. After restarting the applications, the same transaction is retrieved in getTransactionData because the transaction number has the same value. If a queue item variable is processed, Orchestrator deals with retries, so it increments the transaction number. Let's collapse the robot retry flowchart now. In case of a system exception, we invoke another reusable file, take screenshot, to save the screenshot image at the time of the exception. The last step is to try to close all applications. If this fails, we invoke kill all processes to make sure everything is closed. With both close all applications and kill all processes, the files need to be completed, just like init all applications. Alright, this was set transaction status. Going back to the main page, let's have a look at the end process state. First, we can see the same stuff cleaning the environment, trying to close all applications or to kill all processes if that fails, and an if statement at the very end of the process. The condition is system error is not nothing. This is the system error set in the init state, which means that if we get an exception at the beginning, we throw the job failed exception with system error as the exception argument. Now I know what you're thinking. What if the main workflow ends with an exception? Won't that exception pop-up message be displayed? Well, that happens only when the process is triggered in Studio. However, if it's triggered in Orchestrator, the throw activity sets the status of the job to faulted, but no pop-up message is shown. The purpose is to inform the operational team that a job has failed and they probably need to take some action. Now, a job can fail due to multiple reasons, and failing to initialize is only one of them. When needed, additional logic can be incorporated to throw an exception at the end of the process and to set the job state to faulted. Before we conclude this tutorial, let's go through one more reusable file in the framework. The getAppCredentials XAML is used to retrieve the credentials used by the robot to access different applications. There are a few ways of storing credentials, and the preferable way is to store them as secure Orchestrator assets. So that's why we try to get Orchestrator credential. The credential name comes from credential input argument. The reusable file outputs a string username and a secure string password. Secure string is a .NET class designed to handle text that should be kept confidential. If the retrieval of the credentials from Orchestrator fails, we catch the exception, and we use the getSecureCredential activity, which attempts to get the credentials from the Windows Vault. If that's successfully completed, we're done. But if the credentials do not exist, a user dialog will request the credential. After the user writes the username and password, the credentials are added to the vault. It's a simple way to avoid creating credentials manually. After all, we have UiPath robots at hand. This concludes our UiPath Robotic Enterprise Framework tutorial. So let's recap. We started by understanding the main state machine and the overall exception handling and recovery methods. We've then explored each state in detail, the init state with the config file and init all applications. Get transaction data with the two important variables, transaction item and transaction number. Process transaction with the three possible outcomes, success, business rule exception, and system error. We've also explored the set transaction status and get app credentials activities. In the next series of tutorials, we will use the RE framework to implement robust robots on sample processes. We'll start with simple ones while keeping the focus on the framework and slowly move to more complex processes where we'll face many real-life challenges. Sounds exciting, right? Stay tuned.